So, hello and good morning, everyone. I would like to welcome you to our ERCI webinar, AI for the rail sector, Travelers Experience and Seeing Machines. My name is Rico Siegmund, and together with my colleague Lutz Hübner, we will guide you through the webinar today. But at first, I will take 2 to 3 minutes to show you what is ERCI, from which position do we came from. So ERCI is it's a European meter cluster from regional railway clusters. So myself, I'm from RailS, a German railway cluster based in Saxony in the Middle East of Germany. And my colleague Lutz Hübner is from Berlin and the region around Berlin. And with 15 other clusters, we are forming the ERCI network. The big strength of our network is that we can reach out to over 2,000 companies and R&D organizations all across Europe. And so we have the ability to connect our members always with the right partner all across Europe. For this, we have also some activities like the webinar today. That's at least ERCI in a nutshell. And I would take not more time for myself, so I will guide to our first main speaker today, to Mr. Wolfgang Domann from the company EYYYES, and he will talk about using AI for improving safety in railways. So, Wolfgang, please share your presentation, and then the floor is yours. You're still muted. Please unmute yourself.
Yeah. Good morning, ladies and gentlemen. Can you see the presentation already, Rico?
Yes.
Perfect. So a warm welcome from my side and a happy Valentine's Day already in the morning. Thanks you for the opportunity, Rico, that we can present our vision of how to use AI for improving safety in rail. Just a few words about my company and EYYYES. So our vision is that we protect tomorrow's world with AI solutions. And our major core know-how is the object recognition with camera-based sensors. So doing the perception, what happens in front of the camera and giving a digital scenery out of that. Is that what is our core know-how, and this we use for driving assistance systems and for systems where we raise the safety around and inside of vehicles. We are doing this in the automotive utility vehicle market and in the railway market. As the two core markets, we are 35 people, have already registered more than 13 patents and are operating already since 10 years. Now or more than 10 years. And the complete solution which we provide is based on our own neural networks, so our own trained AI, and also on our own software platform. We use a lot of standard hardware, of course, but the full software stack is our own IP. And the major customers which we serve are OEMs on the railway side and on the automotive side, and also tier ones, of course. So starting with the topic, there is not a lot of statistics available here for the examples of light railway vehicles and tram accidents in Europe. But in Germany, they are quite doing, so to say, a very good statistics. So we can take here this as example. What you can see here is the accidents with light railway vehicles in Germany from 2018 till 2021. And you can see that during Corona times, the total amount of accidents decreased, but the fatal insurers with railway vehicles, which means that the people died after this accident, increased or slightly increased also during Corona times. So improving the safety is still a big topic. And what can we do with AI-based camera perception now on such a vehicle? You see here a picture where we tried to show all use cases which you could implement on a railway vehicle to improve the safety. So on the front side, the most important thing is avoiding any kind of collision, either in the full speed, so up to 80 kilometers per hour, or close in front of the vehicle, which we call a moving off assistant. The second option is that you secure the blind spot of the vehicle. This is possible for the right side and also for the left side, of course, for bicycle drivers and scooter drivers and everything which is crossing the way of the rail vehicle on both sides. Then you can improve also not only the warning system, but also the field of view with a better mirror for the driver himself, that he also has a better view over this blind spot area. And then you can do a lot with cameras to detect, so to say, the scenery on the platform, what happens, how many people are still jumping in the train, coming out, or showing just the hand or the legs out. So can the vehicle safely release from the platform, or do you still have to wait because there is still crowded and the risk of accident close to the doors? And last but not least, we can use all of the inside cameras in a vehicle as well to do a surveillance. We made a project this year now for a metro in Southeast Europe, where the use case is that we have to tell the driver if still people are sitting in the vehicle when he's going out of operation in the evening and he's leaving with the vehicle in the storage. So the drivers do not have to walk through the whole vehicle anymore. They get, after 10 seconds, a feedback detecting all cameras inside the vehicle if there is still somebody in the train or not. So with cameras, you can do a lot regarding safety inside and outside the vehicle. And this is, at the end, the aim we have to improve here the safety. What do you need that you can start with such a kind of a system? Of course, you need a camera with the right resolution and the design and the right field of view. You need the AI itself, so the neural network, which is trained for the use case which you want to do, and the objects which you have to detect that you can execute the use case. And you need a proper software, which is on the one hand steering and controlling the AI algorithm, but also calculating the use case itself. So what should you do with the data when you detect some people in the picture? All of the business logic which is necessary, you have to do in an individual software stack. And sometimes you have clear regulations for how a use case should work on, or if not, you have specific customer requirements which have to be implemented to achieve, so to say, the function expected. And last but not least, you need in the vehicle an AI processing unit which can calculate the AI itself and also is processing the software. So let's have a look. What does it mean? What is, so to say, a neural network and deep learning? So deep learning is the way or method which is used mainly to process pictures and to detect objects in a picture. And the neural network is consisting out of neurons. So neurons are like the similar neurons in a brain, and the depth of the network and the width of the network is mainly, so to say, the size of the brain or of the AI, and the connections between the neurons are built up based on the data you give such a small brain in the training that it can learn. So it is like in the school that you give, so to say, the AI a picture, and you say in the picture, this is a car. We call this annotated data or labeled data, that the car is so to say, you see this sometimes when AI is pictured in the screen. We see this later on. And this car is then trained to the AI, that the AI knows, okay, in the picture is here, this box is a car. And when you do the training of this small brain with a lot of data, then you can achieve results. And the more data you use, the better the results will be in detecting objects with a neural network. So, and the process is going like this, that we are allowed to collect data on the street, and that we do this for the last 5 years. And you cannot use all of the data. You have to use, of course, the data in the environment where the vehicles are used. And then you have to be sure that you get data from all situations. So spring, summer, autumn, day, night, weather conditions like snow, rain, or sun. So you have to be sure that you have relevant data and that you have data from all kinds of situations which can happen. And this video data then you annotate with very big neural networks. So we do this automatically. In a lot of cases, this is done manually with nearshore workers who annotate these pictures by hand. But with very big neural networks which are running in a data center, you can do this automatically as well. And when we have this labeled data, then we take this neural network, the small brain, which is then coming into, so to say, a small box in a vehicle. This is not the same AI which is used in a big data center. So this is not a big ChatGPT, but this is a very small one, which is running on a small box which you have in the vehicle. And this we train them with this data. And when it's trained enough and the results are good, so to say, as good as expected, then it's going to be deployed in the hardware. So the result which you get is that you have then an image picture, and this image picture is running through this neural network, and the output is then, so to say, the digital scenery that where a car, truck, or bike is in this picture. And that is exactly what our core know-how is. So our core know-how is detecting an object in a picture, classifying it. So this is a car, this is a motorbike, and here you see also traffic lights classified. Then the next step is tracking of objects. These are these lines, so to say, where are the objects in the picture coming from and where are they going to? And we need a segmentation of the picture, so which part of the picture is relevant for us, because the cars on the other side of the street and also the sky, for instance, is not relevant for our use case. So we do not have to take this part of the picture into consideration. So what we provide then is a digital picture or a digital capturing of the traffic scenery with the camera. And this means that you get out as result, where is an object, what is the object, where is it coming from, and where is it going to. And how this looks then in reality, you can see in the inner city of Vienna, close to the St. Stephen's Cathedral, in the first district. You see that also people here in the dark on the left side and also here on the Manor shop in the shadow are detected quite properly. So the trained CNN in this vehicle on this box is working quite good. And our speciality is that we train the neural networks in the camera view from 3 meters downwards. So especially here in the blind spot situation, you see the bicycle drivers along the vehicle are detected in a very good manner and in a very good way, so that we can use this detection to build a real warning system on it. Because if we don't detect anything, we also cannot warn, of course. So the basis is a good detection in the first hand. But it's only the half mile, so to say. Then we are often asked how this is working in low light conditions or with headlights of other vehicles which are coming in front of us. And here you can see that the detection also in the low light environment is working quite good. So in a city where you have at least 10 lux normally as minimum light conditions, the camera-based AI is still able to detect the objects properly, that it can be used. And after the detection, so if this first block of deep learning is working good and properly, you have then the software framework or the AI framework, which is doing the logic of the use case. So a real warning, image processing and warning is done then here in the second layer. And last but not least, you need to integrate it in the software. So coming to the examples of the solutions for what we are using it is then a front collision warning system, for instance, with the camera only, which detects, so to say, people, pedestrians, cars, buses, trams, and bikes up to 80 meters. And our speciality is that we do not need a second modality, so we do not need a radar sensor. Why? Because we detect also with a second algorithm, so there's a second AI algorithm in, we detect the rail track path, and here we can also detect generic obstacles on the rail itself, because you have to detect bumpers and the end of the track as well with such kind of system, according to the regulation or proposal from VDV 191, of course. So this system is just informing the driver in critical situation, and the driver receives only a warning if there's a real risk of collision. And we see there then a short video that you can imagine how this is working. And we have included this track detection algorithm. So here you see the people detected. This is the first CNN for the object detection, and here the cars on the left side. And the track is a very tricky thing, because sometimes you have the railroad just on the street. Here you have it in the meadow. Sometimes you have black stones which are reflecting a horrible light. So the challenge of having here proper track detection is quite an important one. Why we are doing this? Because this makes the system very easy, because we do not need another GPS sensor locations of the vehicle to know where the vehicle is going. And this makes the system much easier if we can use it in a way like this. So the warning strategy, I will not go in detail with this. You can see this then on the slides. We calculate, so to say, we call it the total time to collision. If an object is coming into our track against us or is crossing our track, then we calculate the time, how long it will take until, so to say, we would touch this object. And based on this time, you can do either information or real warning, or you can make a big sound. This can be configured in the system. The second option, if you use a second camera in the front of the system, is that you have a moving off assistant. What is the major difference? The major difference is that you have here a wide angle camera. So it's a camera with a field of view of 180 degrees. It's more used for people which are coming here with looking on the smartphone and not seeing that here the tram is going or starting. So it's a situation when the tram is moving off with an additional help in a blind spot, which the driver maybe is not recognizing when he's starting. And here also he gets a warning if there is a potential risk of collision. And last but not least, for the front cases, this blind spot information system, which I mentioned already, where you have a similar function like all of trucks and buses, which have to achieve this system for new vehicles by 2024. So the new regulation does not allow that any utility vehicle is sold without the blind spot warning system. And for trucks, for trams, of course, it should be similar, and this can work in both directions or in both sides, that he can see really in the second row behind parked cars as well, bicycle drivers and scooter drivers, and gets a warning when here is a potential risk of a collision. And how looks this, so to say, then when it's working in real life? This is the video capturing with the overlaid AI results of a front collision warning camera. Of course, the driver sees only his picture with his eyes, and this picture is not shown anywhere, but it's just explaining the calculation of the AI system. So what we can see here is the detection of all objects which are around the tram and the detection of the track. When people are coming close to the track, you can see that the system is recognizing it. What is happening here? Cars which are crossing, and this line is, so to say, the track of the car. As long as we are standing still and the track is not hectic or affecting us, nothing happens. And now people are crossing the track or the line, are coming into our direction, and then a real warning is happening. So as long as nothing is crossing our track, nothing happens. And when something is crossing our track, then the system will recognize it and give the driver a warning. And the warning is going in two levels. So it's just recognizing people which are close. This is an information which is coming here, that here are now people standing on the right side. Then he gets an information. And when really people are crossing our track, or a car would cross our movement vector, then it would give out a warning for the driver. So this is how in real life such a system will work and will support a driver, that he has a chance, so to say, to brake, to avoid an accident in such a case. And what is necessary to implement such kind of a system? You just need a computing hardware, a signaler for the driver with lights and sound, and a camera which is mounted behind the windscreen, either glued on the windshield or it can be mounted on the roof top in front of the vehicle. Yeah, I will skip this. I will distribute this in the slide here. You can see how such a system can be installed. It is very easy because it does not need any kind of data of the vehicle. So it's also can perfectly be used for a retrofit usage in existing vehicles. And summarized, what I have told is we need for such kind of a system only the camera, which means that there is no outside mounting of any kind of additional sensor necessary. So the installation is really simple. The camera will be calibrated once the system is installed. This can also be done very easy. And we calculate then the movement prediction, which we have patented for all of the objects which we detect. And based on this movement prediction, we are making these warnings with light and sound. And we can provide all of this data via an interface so that people have also the chance to take our data and use this data also for autonomous functions in the vehicle. So this is mainly interesting for an OEM who wants to use our perception. Finally, I want to mention that we can use, of course, the perception, as I told at the beginning, also outside the platform at the vehicle and use the vehicle cameras which are mounted outside on the track. And this is a view of cameras on a vehicle which is driving at the moment through Austria and is, so to say, a test vehicle for the Austrian Railway organization in an R&D project where we try to find out how really these pictures and detections of the persons can improve the self-handling of such a vehicle. And I mentioned already that we have an order from a metro vehicle for the inside CCTV detection, where you can then use the system to detect if people are still in. We can also detect if a lot of people are in, so we can give a passenger load factor. We can also detect garbage and waste now in the newest version. So the use cases are really depending on the expectation of the clients and customers. So there are a lot of ideas and solutions in the future possible with AI. We are providing the technology, but clients and operators who do the business every day have to provide us with the ideas for which use cases to use the AI. Yeah, thank you very much. With this, I'm on the end of my presentation, and I hope it was interesting for you to start into the Valentine's Day. Thank you.
Yeah, thank you very much, Wolfgang. Yeah, are there any questions from the participants?
Well, we have already prepared 3 questions to be seen in the slide. Maybe it's a first task to answer these 3 questions, partly already answered, I'm feeling.
Yeah. So what we often get asked is the question if an AI system is learning during operation. And unfortunately, no, it is not. Even this is also not allowed. So we train an AI system offline, so to say, before it comes into operation. And it's like a child which is going into school. Everything which has learned in school it knows then later on, and it can use it to operate, and anything else has to be retrained, and you have to go into school again. So AI does not learn when it's already implemented in a vehicle.
So second question, do you only use camera and no other sensors?
We use only the camera because the camera core know-how is our major core competence. And the cost of the cameras are at the end, it is the cheapest sensor if you compare it with LiDAR or other more intelligent sensors. And the integration of other modalities is also very complex and cost has a lot of cost, so to say, following on. So with the efficiency of cost, this is the way why we use only the camera as sensor.
Yeah, third question, I'm feeling that you already answered it with your presentation.
Yeah.
Yeah, and it works. Is the simple answer, I would say. There is a fourth question coming from the chat, and there are another questions coming from the chat, but the one is how do you assess the reliability of your AI system?
This is a very good question. So there is no, so to say, official way because especially also regarding seal and functional safety, this is the whole challenge for the automotive and the rail world because AI cannot be approved regarding functional safety at the moment. So there are lots of R&D projects going on to prove AI. What we are doing is that we are defining KPIs with our clients, especially the OEM clients who are buying our perception software, where we define for which kind of percentage, so to say, the AI is reliable to detect a person or a car or a truck in which kind of situation or weather condition. And based on these KPIs, we test the system then against real test data, and we have to achieve, so to say, these KPIs. And if we don't achieve this quote, we have to retrain or retest the AI. So there are methods available how you can do this, but these are not methods which are already in, so to say, a common approval scenario that you can go with that for TÜV to TÜV or any other official organization.
So there is another question coming from the chat. Hello, this may have already been mentioned, but from what I observed is in previous slides, the objects detected are required to be larger than 1.5 meters in height. Can the system also provide warnings for persons with reduced mobility or other objects such as strollers and buggies?
Yeah, so this is answered very easy. It's not depending on the size. Here, up to 80 meters, we say that we have a reliable detection with peoples which are larger than 1.5 meters. But everything which is closer, we detect every person independent if she's lying on the ground or sitting in the wheelchair. So in all situations, we can detect it. Besides that, we have now also trained a neural net which is detecting especially wheelchair persons, which is used for the traffic light improvement. So it's an intelligent traffic light sensor. So when you are waiting on the cross that you want to move over the street, then the sensor is recognizing you with the camera. You don't have to press the button anymore. And wheelchair drivers are specially detected and receive then a longer time of green, that they have more time to cross the street than other normal persons. This is already implemented, and yes, we can detect this kind of vehicles or reduced mobility persons as well.
Yeah, we have some more questions. One participant asked 3 questions, and the first one is, how is the interface between the system and the driver?
Yeah, the interface is this signaler, which I mentioned. This is a yellow, red light, and a warning horn or a signal horn. It can be a signaler which is delivered from our side, or it can be integrated in the cockpit of the driver.
Yeah.
And then the driver has to do the decision, is he braking or not? So the driver, it's like in a normal car vehicle. You have to decide how to use the others functions.
How is the driver reported that there is a warning?
Yeah, he receives the light and the horn.
Yeah.
I'm not sure what he means with reported.
So then I have a question. Have you considered that the system breaks the train in the event of a real impact?
Yeah, this is something which where we come into this functional safety discussion. The OEMs can implement this, of course, because it's their vehicle. We are the experts for the perception. We provide the signal, so we know when it should brake, so we can give him a digital signal. But how and if is something which an OEM has to implement in the vehicle. It's possible, but it's not our job anymore.
Yeah.
But,
okay, we have some more questions before coming to the next presentations, and I'm struggling a bit to get all of them into the slide. How fast does the camera can detect if a passenger came into the train path? Is there any time consideration for this?
Yeah, the latency is 200 milliseconds for the detections. So after 200 milliseconds, the system knows that there is a person. The actual field of view of the camera and the design is made that up to 80 kilometers per hour, the system is working properly. It could work also in a far distance, but then you would have to reduce the angle and the view of the camera. Even a different setup, it would work also for 200, 250 meters, for instance.
Yeah, second question, how do you handle the issue of model exploitability when it comes to using deep learning vision models?
How to handle the issue of model exploitability. So I'm not pretty sure what is meant here, but we use several AI models in a use case. So as I mentioned, detecting the track, it's a complete different CNN as detecting just the 6 classes of objects. So we reduce every CNN to that what it can achieve in a good quality, and then we implement a second or a third or fourth algorithm. We have solutions where 10 or 11 CNN algorithms are working in parallel.
Yeah. The question was not about the question was not about the exploitability, but about the model explainability.
Explainability.
Yeah.
Yeah. The same as I answered before. We are in an R&D project with TÜV together, where we work on how the AI is deciding and when it is deciding. So we work on that we know in the different layers of the CNN what is happening, that we should say open this black box, that we just have an input and an output, and get more understanding of how the AI is answering. This is a topic for R&D projects, and at the moment, not something which is already common know-how or common knowledge at the moment.
Yeah. The next question was, could the system detect objects such as trees or objects of varying sizes on the railway track?
You can train a CNN for all kinds of objects. For instance, we are now integrating a special function for headlight detection. of other vehicles, and we are integrating sign and signal detection so that the signs and the signals for the driver are going to be detected as additional function. But this is also done with a new CNN, which is only doing this kind of detection. And you can train at least every object for a CNN that it can be detected. So if you train it for the trees or the class of trees, it can be detected as well. But at the moment, this class is not used, of course.
Yeah. What is the extent of to which the system depends on the human? If the engineer does not receive the warning signals, is there any system that can compensate for that and prevent a collision?
At the moment, it's unfortunately forbidden that can work alone. So it is depending on the human, and to rely on this. It's a driving assistance, like in the car. In every new car you buy driving assistance, but you are responsible as driver for driving and steering the car. And here it is the same.
Yeah. Is there an intervention in the train brake?
I think we answered this already.
All right. Then have you measured the delay time between the appearance of an obstacle and the signaling to the driver?
Yes, 200 milliseconds.
And the last question for the moment, we all know that every system as an integrated product of hardware software sooner or later fails. Is it foreseen any kind of mitigation design strategy regarding the hardware? Maybe any redundancy?
Yeah. So I think there is all of the vehicles operators have their service contracts with the OEMs and the tier ones. And I think if a system is failing or is not working properly, it is going to be detected very fast for the driver. And it also tells the driver that it's not working over the signaling element. And then the hardware will be changed like it is done for all other systems as well.
So the last question is, will these slides be provided? I answered with yes. And if there are no any obstacles against it, we will provide a PDF version of the slides, as well as we will provide a recording of this webinar in the YouTube channel I mentioned later. Thank you so very much for the moment. I see there is another question, but maybe you have the chance, Wolfgang, to answer this directly in the chat. So I will take the chance to announce the second presentation of our webinar. It's the explosion of generative AI. And it will be performed by Laia Garriga-Mas. She is a technology transfer manager of the Applied Artificial Intelligence Unit of the Catalan Research Institute called EURECAT. And Laia, it's your floor.
Okay, thank you very much, Lutz. Well, first of all, thank you for inviting me to do this this presentation. I will share my screen. Hope everybody is seeing the presentation already. Is it working? Okay, thank you, Lutz. Okay, then, okay, as the title was, the traveler's experience and seeing machines, I will focus my presentation in the part of traveler's experience. As all of you know, the AI in the rail sector, it's you know, a tool that we can use in a lot of different ways. We have already talked about AI in infrastructure. Maybe we can talk about, right now we are talking about one use of AI for the rolling stock and the security in railway. And I will focus more in traveler's experience and what we can do in this side and how the generative AI can help us. Let me talk a little bit about EURECAT. We are a technological center, so we help other companies to reach their goals and be more competitive in their markets. We have 4 main areas. The industrial areas where we work about advanced materials, functional printing devices, collaborative and cognitive robotics, etc. Then we have a digital area. I'm part of this digital area where we do projects in data science, artificial intelligence, cyber security, and so on. Then we have a third block, biotechnology area. This is maybe not really have to do anything with rail, but we do things like nutrition and health. We work in omics science and biotechnology. And then we have a fourth pillar that is a sustainability area, where we work in a lot of projects with water, all the cycle water matter, the soil, air, energy, waste, environmental impact, and so on. We are now in more than 700 people. Our income is about 55 million euros, and we work with more than 2,000 companies. The team that it's working in AI, applied AI projects, we are more than 45 people now. We have the people in Lleida, Barcelona, the most of the team in Lleida, but we have people also in Barcelona, Madrid, Bilbao, Zaragoza, and so on, all of them placed in Spain. We work very hard in the industrial area, aerospace, agri-food, logistics, construction, energy, water, environmental, and climate change. So we do projects really on industrial markets. The solutions are typical solutions in AI, like decision support, prescriptive management, digital twins, and what-if scenarios, etc. And the technologies, we try to be in the state of the art of the AI technologies. So all of them, we work in all of them. Okay, we will go through itinerary towards digital decade. We will talk a little bit about data spaces in the railway sector, and we'll see an example in the tourism sector to see how they handle it and see if we can handle it the same way in the rail sector. We will talk a little bit in generative artificial intelligence, and we will see some applications in the railway and the future challenges. Okay, why are we talking so much about artificial intelligence right now? It's because we have, some goals in Europe, and we know that we are in the digital decade. So Europe aspires to empower common companies and people for a more sustainable world, a more purpose and human-centered digital future. So we have, like a mantra in there, and we have to work to reach it. And also the road, it is defined a road to digital decade, like a policy program with the specific milestones and objectives for 2030. So we have like guidelines from Europe to this digital transformation. Which are these main mantras? We have the milestones for 230 made by Europe's digital decade are in 4 pillars: infrastructure, business, skills, and government. What we try to do is digitally enable citizens and have a rapid growth of ICT professionals, because we have a really lack of professionals in there. So we are working really hard to teach, to grow all this performance and professionals. Then we have secure and sustainable digital infrastructure. We work really hard in like gigabyte connectivity for everyone, like high-speed mobile coverage for everybody to be connected. So we are working in this pillar for sure. And then we are working also in digital transformation of all companies. We are trying, to scale up these companies that are not only in the rail sector but everywhere. And then the digitalization of the public sector. The governments are all of them working to have 100% online. Everyone, let's say that everyone can do everything online. So having this in mind, all of sectors are working in this concept, the data spaces, to share data in a common way. And we do the same in the railway sector. So what is a data space? Why we have to work in data space in the rail sector? There is a lot of people that say that data spaces are like really nice to have, but like hardly impossible to reach. But the reality is that in the rail sector, we're still talking about this. A data space is an ecosystem in which voluntary we share data in a voluntary way within a secure and trustworthy environment. So everybody knows how to work with this data. It is organized with a regulatory and technical mechanism that enables everybody to use this data. Then why that is so important? Because it enables the people with the same ecosystem to work with secure data and also with a lot of amounts of data. This past week, I was in a seminary doing like for improved business. And one of the teacher was saying, with no data, there is no paradise. I got this phrase because it is like this: with no data, there is no future, there is no paradise. So if we are able to share all the amounts of data that we are generating in one unique space, we can do so many things with this. I will share you an example in tourism in Spain. The Spanish government is pushing really hard to have a data space in tourism. And they built a unique concept to be able to share all the data that is collecting of the different parts of the value chain, talking about tourism. And really, they are reaching this goal. They have an app store, like a marketplace of services, of digital services for the different companies to be able, to manage the different destinies. Also, they have common services, like 20 functionalities that can be used for the different operators. Also, they have like 20 use cases, all in one box. So you can, try how to manage different services by your own. Also, they have an open innovation box like services to provide, tools to do new innovation or get engaged in different projects. Also, they have a big, huge data space with all the tourism data that is generated for different industries, like public and private data, all in the box, following the Gaia X project, and so on. So that's a very nice example of a data space, and I put it in here because in the rail sector, we're still discussing how these data spaces have to be. We have some examples running by some operators, but they are still data spaces in one company. They're, we started to play in different projects to see how they have to be. We have a current European rail regulatory framework that tries to define how the rail sector have to move on in this matter. But again, we're still discussing in this field. So, we have to move forward and see if we really are able to reach these kind of projects. Okay, let's go to generative artificial intelligence and how this could help to engage people in the rail sector, and how we can, improve the user experience. Let's start with what is artificial intelligence. Let's go to the beginning. Artificial intelligence is making machines. It's one of the answers, but there are more of it. But for me, it's making machines imitate human intelligence to perform various tasks. And if we go a little bit farther with the machine learning, these machines, they can learn patterns by processing large volumes of data. And again, with no data, there is no paradise. So we need data. If we see the traditional artificial intelligence, a little bit of it, models are trained specifically for each situation. For example, like neural networks for classification and prediction. They balance data sets and domain-specific level data, and they are unimodal. Models are specifically trained to work with text or images or performance or whatever, but they are unimodal, let's say. The generative AI, it goes deeper on it, and the foundational models train in generalist way with huge volumes of data. Generative AI is not possible if we don't work with really large and huge volumes of data. GPT technology, it's a generative pre-trained transformer. It's the core of the generative AI. And it has enormous ability to process very long text, make summaries, give answers to specific questions, produce coherent text. We know that already because ChatGPT has already shown everybody that it's possible to do this. It is multimodal. It has the ability to generate multi-language text, video, audio, code, or data simulations. In railway, it's really important, this part, to do new code or data simulations is one of the pillars of the generative IA. If we talked about infrastructure or rolling stock, if we talked about user experience, we can talk like, generation of multi-language text, video, audio, and so on. And also it's multifunctional. Like you have in one platform, like text generation, translation, summarization, content structuring, and so on and so on. So more powerful. Let's see an example of OpenAI. Like if we try to ask an OpenAI to do an armchair in the shape of an avocado, for sure, OpenAI will try to give us some ideas of how to shape an, armchair with the shape of an avocado. But who knows if this is like, ergonomical or sustainable, or are we going to be able to produce this in a producer line? It only gives us some ideas, but it is so powerful because with these ideas, we can still working in the product design and have finally really a market design and product. Another example of OpenAI, the image that you see in the purple mark, it's a picture, a real picture. And if I do this picture to the OpenAI platform, it is able to do the whole framework aligned with the picture. So what you see in the external purple square, it is all invented for the OpenAI. So again, really powerful. All these images are not real, are made in OpenAI platform. So we can generate new images with talking with the platform. So if I say I want a picture of a teddy bear walking in Down Street or in Barcelona, it can generate the image if I give to the platform the right inputs. Another example, we can do music, new music, just giving it some text. So this is really powerful if we use it in a right way, and if we use it to, make new experience for the travelers, for the people that takes the train or whatever. So just to think about it. Okay, just a flash. We can work when we have short, not really a huge amount of data. We should probably work in supervised models, because we probably will have a higher accuracy, and even if it's really labor intense and the annotation cost is high, probably we will reach more accuracy. When we have massive raw data, probably we should work with unsupervised models to reach better performance. If we go back to the generative artificial intelligence, and we are working in user experience, we have to be careful, because if I ask, for example, to a generative AI, like, I don't know, next Friday I want to travel to Hamburg to Barcelona, I have to arrive before 11, and I don't want to spend more than 30 euros. And I ask what options do I have, probably the platform will get back with an answer. There are applications that will quickly tell us that it's not possible, because if we look at, for example, Google or any searcher, it will turn on it is not possible. But if we ask generative AI, it probably will come with a purpose and with an alternative, because it will try to invent combinations. So we will have to be really careful, because generative AI, it's not a searcher. It's they try to always come up with an answer, even if it's trustable or even if it's not. Okay, so generative in AI will even we will they will try to find a context, so probably will reach you with an answer. So how we can give more trustability to this kind of models, giving context. So, protect the income data, do some plugins, integrate with third-party applications to make sure that the answers that we are giving are correct, and prompt engineering for, do the good questions to the platforms to have better outcomes. Some applications in railway, how we can use generative AI in specific applications in railway. Just to have, an overview. We can do, of course, simulation data. If we talked about, for example, predictive maintenance, or solutions in the infrastructure or rolling stock, simulation is a really important tool, not only to plan operation, but also to improve all operation. Generative AI can be used to generate realistic simulation data for the future, and also, be capable to see locations and movements of trains, not only in this moment, but also in the future, and also have a lot of information about behavior of passengers in the stations, as we've seen in the presentation before. So we can use this kind of technology to improve all the operations in railway. Also, we can work in creation of images and videos for training and simulation, not only for user experience, but also to train the people that will be in this part, in the operation part of the railways. As we said, we can use it to create new images and videos of trains, stations, railways, and other elements of the railway environment. These images and videos can be used to train object recognition models, route planning, simulate emergency air scenarios, and so on and so on. So huge, space to develop. Also, we can use it for the generation of designs and infrastructure planning, as we can simulate, as it has the capability to simulate. We can use it to generate designs for railway tracks, stations, bridges, and other elements of railway infrastructure, and simulate how it will be performed in the future. And we can optimize and maximize operational efficiency, minimize construction and maintenance costs by using this kind of technology. Also, we can work in generation of schedules and route planning for sure. We can use, to be more efficient in program routes, taking into account factors such as passenger demand, and so on. More examples: creation of landscapes and virtual environments for training and planning. We already talked about this. Customization of travels. Can be used to analyze user behavior, data, and personal preferences to deliver highly personalized journeys and experiences. So really, really deep on it. Also, we can do virtual assistants and chatbots. If you work in for people that have specific needs to travel, virtual assistants made with generative AI can be really, really strong in this field. So a huge place to do projects in this field. And also, we can work in smart destination management. If we think about, a really nice place where I can talk with someone and say, hey, I want to go from point A to point B, and also I want a really nice experience in the point B. What can I find in there? So you can manage mobility destinations. You can improve traffic management. Also, you can, do highlights for the visitor experience, and so on and so on. So we have a lot of things to do in here. And to finish my speech, we have to be careful because we have on the table a huge question. Can we trust large language models? Can we trust generative AI right now? Okay, the challenges are that we require tons and tons of memory because we need a lot of data. So here we have the first, let's see, the first point to reach. Also, they are hallucinating. So we already talked about this. We can ask something to generative AI models, and they can reach about an answer that has nothing to do with the reality. So we have to be carefully here, and we need a lot. We still require experts to do cross validation with the original sources. They do not manage typical cases. And we know that critical cases are precisely rare. So to train this kind of platforms, we still have problems. Also, they still be black box. It's my last slide. Human in the loop supervision. So we still have a lot of human supervision. And I want to comment this also because the BIs can be critical in this kind of platforms. They don't know about gender, race, and so, or inappropriate content. So we have to be careful in that. And the regulation is pending already. And what's next? I took a phrase of the MIT Technology Review that they say now we are in generative AI is just the phase. What's next is interactive AI. So this is it by my side. If anyone wants to go deeper on it, just you have my contact in here. Thank you very much.
Yeah, thank you, Laia, for your speech. And we've collected some questions from the chat. And the first one is, what are the main challenges of generative AI? What comes next? And your speech the last slide was about what comes next. Yeah, have you got any additional answer on this?
No, I think now we are in just knowing what we can do with generative AI. And yeah, the next phase, I think it will be the interaction. And well, we'll see what happens in the future.
Yeah, can generative AI modify current business models in the sector?
I think they will change a lot. We are working now with a company that is Mazats, is a company that makes a subsystem of the rail of the rolling stock that are the doors, and we made a platform for predictive maintenance. And now they are changing the business model because they were a provider, only a subsystem provider, and now they are turning on product and servicer providers. So for sure, the business models will change, and we will have to see how all these subsystems are integrated, how we work with those data spaces, and how we can, go through our business with all this data and with all these new platforms.
Yeah. Are you using any of your solutions for digital twins?
Yeah, for sure. Because when we talk about digital twins, as we understand digital twins, because a lot of people talks about digital twins, but it's like when we talk about the smart cities or about artificial intelligence in general, digital twins is a concept that may have a lot of ways to work on it. As we understand digital twins is how to do what if scenarios in the future, what we need to create to do what if scenarios. And here all the generative AI, it's the base of these objectives. So for sure we use this to do digital twins.
Next and maybe last question, do you know if there are any platforms really ready for this kind of generative AI models?
Yeah, in EURECAT we use a lot of these platforms, but there are several. I should ask my technical team to give you some examples that we use already in EURECAT. We don't only use one, because the examples that you've seen, like images, text, are different platforms where we can use to do these kind of things, but also to do code. There are several platforms. We don't use only one. We use several of them. Specifically for railway, I should ask the technical team, because we are using some of them to do the digital twins of mobility scenarios and so on. So I can ask for it. But as I said before, you need a lot of supervision. You need experts to do the right data sets, the initial right data sets, and work with them to have the real or the most real scenarios or the future scenarios. So it's not easy, but it's possible right now.
All right. Thank you very much, Raya, for your interesting presentation. And to give a short summary of your presentation, it is to be seen in the bottom of the slide, no data, no paradise. Thank you very much. And yeah, you will have the chance to give us a feedback on this webinar by using the short questionnaire we installed via forms. To give us some ideas on future topics of the ERCI webinar series. And yes, there was another question to Wolfgang, but it has already answered into the chat, I saw. So, yes, you are invited to use our short feedback questionnaire, only 2 minutes or 1.5 minutes to answer, to rate our presentations and give us some input for future topics for ERCI webinars. I will come to mention some activities ERCI is involved and may be of interest to you. There is a project called Success. It is to support European SMEs of the rail supply industry in successfully applying to public procurements in USA, Canada, and Norway. And within this project, Tenders Watch newsletters has been installed for these 3 target markets, and you may contact the persons mentioned in this slide and in the chat to receive or to subscribe one or more of these Tenders Watch newsletters, which are issued regularly. I think in a weekly base. So it is every time the latest status. The project itself is running until the 30th of June in 2024. And if you want to learn some more on the project, I kindly invite you to visit the project website. Maybe Rico is also putting this website into the chat. Then we have installed during the already finished STARS project an opportunity for B2B meetings, basically on advanced technologies for your business, maybe also on other topics if you like. It is only that you create a short profile on this platform. It's a B2B matchmaking platform, and in general, you can arrange meetings with other platform participants at any time. Please give us some information on your business and to give the other participants the possibility that they might find your business interesting and might come in contact with you. The platform is still open and will remain open until the 30th of September in 2025. That means nearly over 1.5 years, you have still the possibility to use these STARS B2B meeting platform. Then, I already mentioned that all ERCI webinars are recorded and will be available on the STARS YouTube platform. Also, this recording, please give us 1, 2, 3 more days to finish this. And then in the follow-up email, you will receive the link to the recording as well as the 2 presentations. And for sure, also some information on the upcoming ERCI webinars. So I want to mention the last project, which is led by ERCI itself. It's a Europe's Rail project called Leader 2030. The main contact person is Guido Ancarani. It's our operations director at ERCI. And it is on learnings for European autonomy to deliver Europe's rail in 2030. If you see the simple example of pencil, what material is needed for pencil, you can see that the different materials are available in different countries all over the world. And so the value chain of a simple pencil is quite complex. And if you can imagine the same for the railway industry, how they receive their raw material, it is for sure more complex than the example of a pencil, but it's a very complex issue. And if you have some disruptions and gaps in the value chain, it might be a problem. So the keywords for these projects are the supply chains, needs of the future, supply constraints, risks of supply availabilities to deliver EU rail innovations, and strategic options to ensure resilient solutions and autonomy within Europe. This project has been started to give some paths to solve such gaps and disruptions in the rail value chain when you see the raw material topic. We have some crisis in the world for the moment, and we have the climate change here, which has a huge impact also on value chains, and there might be some difficulties, and we have to tackle this issue, and Eurail want to tackle this issue to first identify what are the real issues for the rail supply industry for the moment. So I will take this slide as first one, and the basic for giving advice to Europe's rail is first to have a study in the past to identify the alerts for the future. That means all rail-related companies are invited to take part in an EU consultation to strengthen the databases on which such mitigation measures could be defined. And this EU consultation is available in several languages. These are the languages of all of the ERCI member clusters. It's in English, in German, in Spanish, in French, in Italian, in Polish, in Swedish, in Serbo-Croatian, and in Turkish. And all the links to these EU consultation are also available in the chat. Thank you, Rico, for this. And you are kindly invited to strengthen or to increase the databases on which the project is able to decide or give some advice to the Eurail joint undertaking how to tackle this issue, how these value chains could be more resilient. And for sure, it is a question of innovation, how to ensure innovation also with that points and with that measures which are given to the European rail industry. So the partners of the project are ERCI itself with its 17 members. And the second partner is the French Technology Center Relanium. It is the Geo Competence Center in Freiberg in Saxony in Germany, and the Technopark in Istanbul. And you are kindly invited to take part in this survey. So coming to the end of the webinar, and it is 11:30, so it's time to come to an end. I kindly want to announce you the next two webinars of ERCI. The first one is on norms and standardization for trackside equipment, especially it's on the presentation of the idea of a new standard for type tests for signaling in telecommunication equipment, which is installed trackside. It's in 2 weeks. We are again starting at 10 o'clock Central European Time. Registration is already possible, and I guess that Rico already put the registration link into the chat, as well as to the next webinar. That means the webinar in 4 weeks. Also Wednesday, 30th of March, 10 o'clock Central European Time, on seamless vehicle positioning in rail via GNSS and ultra-wideband sensor fusion. Also very interesting topic. We have also engaged 2 companies which are presenting their solutions, and the registration is already possible. Please use the opportunity. For sure, you will receive also all that information with our follow-up email. And at the end, I have to thank you, and not only me, but also Rico from EYYYES, and for sure, in the name of the presenters of Laia and Wolfgang, for your participation. We are very pleased to have you as and such a good audience with such good questions, and we hope that we can see in one of the next ERCI webinars again. Have a nice day and see you soon. Bye bye.
Thank you.
Bye-bye.